What if the universe had shortcuts? What if instead of taking thousands of years to reach the nearest star, we could cross the galaxy in the blink of an eye? This is the promise and the mystery of wormholes and warp drives. Ideas that sound like science fiction, yet come directly from Einstein's theories of relativity. Today we'll explore what wormholes are, how warp drives could bend space itself, the enormous problems in our way, and why scientists still believe these concepts might one day take us to the stars. For centuries, humanity has dreamed of traveling beyond Earth. Rockets took us to the moon. Probes have reached the edge of the solar system. But even our fastest spacecraft would take tens of thousands of years to reach the nearest star. The speed of light, 300,000 kilometers per second, is the ultimate speed limit. According to relativity, nothing with mass can go faster. Space, it seems, has locked us in, unless there are loopholes. A wormhole is one such loophole. Imagine space-time as a sheet of paper. If you draw 2 points on it, the distance between them is fixed. But fold the paper so the points touch, and suddenly you've created a shortcut. That's what a wormhole could be. A tunnel through space-time connecting 2 distant points. Enter one side near Earth, exit instantly near another star system. No long journey in between. Sounds perfect, but wormholes come with big problems. They might collapse as soon as anything tries to pass through. They could expose travelers to lethal radiation. And keeping them open may require exotic matter, substances with negative energy, something we've never observed. So far, wormholes exist only on paper, but the math suggests they could be real. Another idea is the warp drive. Instead of breaking the speed of light, it bends space itself. The most famous design is the Alcubierre Drive, proposed in 1994. The idea: contract space in front of the ship, expand space behind it. The ship doesn't move faster than light. Space does. The bubble carries the ship forward at apparent faster than light speeds. In theory, it avoids breaking relativity. But again, there's a catch. A warp bubble would require exotic matter with negative energy. Early estimates said you'd need more energy than exists in the entire observable universe. Later refinements reduced the requirement, but it's still beyond our reach. Even if we could create it, the bubble could be unstable or destructive. The ship inside might be crushed by tidal forces. Still, the warp drive remains one of the few serious concepts that allows faster-than-light travel without breaking the known laws of physics. So why don't we have wormhole gateways or warp bubbles yet? The first problem is energy. To hold open a wormhole or fuel a warp drive requires unimaginable amounts of energy, orders of magnitude beyond anything humanity can currently produce. The second problem is stability. Wormholes might collapse instantly. Warp bubbles could evaporate before they form. And if they did form, they might rip matter apart inside them. The third problem is paradoxes. Faster-than-light travel opens the door to time travel. With wormholes, it might be possible to step into one end and emerge before you left. That creates causal paradoxes. Problems so severe that some physicists argue they might prevent wormholes from existing at all. Finally, there is safety. Even if we could build these machines, would using them destabilize the universe? Are we playing with forces we don't fully understand? And yet, scientists still study them. Why? Because the dream is too big to ignore. Our current rockets will never carry us across the galaxy. If we want to explore beyond our local stars, we need something new. Wormholes and warp drives are extreme, but they are rooted in real physics. Already, we experiment with quantum entanglement, dark energy, and black holes. Perhaps exotic matter exists, waiting to be discovered. Perhaps new theories will reveal ways to stabilize wormholes. History shows us that yesterday's impossibilities often become tomorrow's breakthroughs. Airplanes, rockets, quantum computers, all once thought impossible. Could wormholes and warp drives join that list? If humanity ever harnesses them, everything changes. We could colonize planets in distant star systems, travel across the Milky Way in weeks, explore galaxies millions of light years away. We might meet other civilizations, or discover that we are alone in the cosmos. Either way, the universe would suddenly feel small. But for now, they remain on the edge of science. Ideas waiting for new physics, new technology, and new imagination. So, are wormholes and warp drives fantasy? Or are they glimpses of our future? Only time will tell. Subscribe to ScienceMined for more mind-blowing science facts every week. Because when it comes to the future of space travel, today's impossibilities may become tomorrow's first steps across the stars.